Ever found yourself pondering about how your computer's memory operates? Well, you're not alone. It's a subject that intrigues many, and for good reason. Computer memory is the workhorse of any computing system, be it your personal laptop, a supercomputer, or even the smartphone in your pocket. It's the essential component that allows your device to process data, run your favorite applications, and even surf the internet. Today, we're going to focus on a specific type of computer memory, random access memory, or as it's more commonly known, RAM. RAM plays a crucial role in your system's performance, and understanding its workings can help you better appreciate the complexity and the marvel of modern computing. So if you've ever been curious about your computer's RAM, you're about to unravel its mysteries. Stay tuned as we delve into the fascinating world of computer memory and explore the inner workings of RAM. Diving into the world of computer memory, one cannot miss the term RAM. But what exactly is RAM? RAM stands for Random Access Memory. The random in its name refers to the fact that any byte of memory can be retrieved without touching the preceding bytes, making it fast and efficient. RAM is a type of volatile memory. Volatile might sound a bit dangerous, but in this context, it simply means that the data stored in RAM is temporary. It stays there as long as the computer is running, but the moment you shut it down, poof, the data vanishes. That's why any unsaved work is lost when a computer unexpectedly turns off. Now you might be wondering, why would a computer need such a fleeting type of memory? Well, that's where the true beauty of RAM lies. When you're working on a computer, whether you're typing up an essay, editing a photo, or playing a video game, you're not constantly saving every single change. Instead, all those changes are stored in RAM, so they can be accessed quickly. Essentially, RAM holds all the data your computer is actively using. And here's the kicker: the more RAM your computer has, the more information it can handle at once. This directly impacts the performance of your computer programs. If your computer is a juggler, then RAM is the number of balls it can keep in the air at the same time. The more RAM, the more balls, the better the performance. But don't be fooled into thinking that more RAM always equals better performance. There's a limit to how much RAM your computer can effectively use. After a certain point, adding more RAM won't make your computer any faster. It's a bit like a juggler again. Once they're juggling as many balls as they can handle, adding more balls won't make them juggle any faster. In simpler terms, think of RAM as your computer's short-term memory. Now that you know what RAM is, it's time to explore its components. Dive into the intricate world of random access memory, or RAM, and you'll find it's composed of a few key parts: memory cells, address lines, and data lines. These are the fundamental building blocks that allow RAM to store and retrieve data in a flash. Let's break it down. First up, memory cells. These are the heart of RAM, the places where data is stored. Each memory cell is like a tiny storage box that holds a single unit of data, which is typically measured in bits. A bit is the smallest unit of data in computing, represented as a 0 or a 1. Now imagine billions of these memory cells all lined up in rows and columns. That's your RAM, a vast grid of data storage waiting to be filled with information. Next, we come to address lines. Picture these as the map to your data. Each memory cell has a unique address, a bit like a postbox has a unique postcode. When the processor needs to retrieve or store data, it sends the address of the required memory cell down the address lines. The address lines guide the processor to the right memory cell, like a GPS guiding you to your destination. And just like how a city would be chaotic without a proper addressing system, the same goes for RAM. Without address lines, finding data in the sea of memory cells would be like finding a needle in a haystack. Then we have data lines. These are the superhighways of information. Once the processor has located the correct memory cell via the address lines, the data is transferred along the data lines. They work like the delivery trucks, carrying data from the memory cells back to the processor, or vice versa. The speed at which this data travels is crucial to the performance of your computer. The faster the data can travel, the quicker your computer can process information. To sum it all up, memory cells are the storage units, address lines are the navigational system, and data lines are the transportation mechanism. Each plays a vital role in the functioning of RAM and subsequently your computer. They work in harmony, storing and retrieving data quickly and efficiently, allowing you to switch between applications, load web pages, and play games without a hitch. It's fascinating, isn't it? How these minute components, which are invisible to the naked eye, are responsible for the smooth functioning of our digital activities. Whether it's streaming your favorite show, playing an intense video game, or simply browsing through social media, it's all made possible by these tiny but mighty components of RAM. Understanding these components is key to grasping how RAM works. Remember, every bit of information counts and every microsecond matters in the world of RAM. So the next time you click, scroll or swipe, take a moment to appreciate the intricate dance of data happening right under your fingertips. Armed with knowledge about the components of RAM, you're ready to learn how it functions. Let's delve into the fascinating world of random access memory. First off, the fundamental operation of RAM revolves around two key processes: reading from and writing to the memory. But how does this happen? The magic lies in the orchestration of address lines and data lines. Imagine RAM as a massive grid of rows and columns, each intersection housing a memory cell. This grid is navigated using address lines. When the computer needs to find specific data, it sends a binary number via these address lines. This binary number is decoded into a row and column coordinate, pinpointing the exact location of the cell holding the data. Now this is where data lines come into play. Once the memory cell is located, data lines are used to either retrieve or store data. If the computer is reading from RAM, the contents of the memory cell are sent down the data lines to the processor. If the computer is writing to RAM, the data is sent from the processor through the data lines and stored in the memory cell. It's important to remember that each memory cell can only hold 1 byte of data, which is equal to 8 bits. This might sound small, but consider that a typical RAM module these days can hold billions of these cells. Also, it's worth noting that this process is incredibly quick. The random in random access memory refers to how any memory cell can be accessed directly and swiftly, regardless of its location. This is unlike other types of memory storage where data has to be sequentially accessed, which can be time-consuming. In summary, the process of reading from and writing to RAM involves the collaboration of address lines to locate a memory cell and data lines to retrieve or store data. This intricate dance happens at lightning speed, enabling your computer to perform multiple tasks simultaneously. So every time you're using your computer, this complex process takes place in the blink of an eye. Having delved deep into the workings of RAM, let's summarize the key points. Random access memory, or RAM, is a type of computer memory that is used to store and access data that is being actively used. It's a crucial component of your computer, acting as a temporary storage area where data can be quickly read and written, allowing your computer to perform tasks efficiently. RAM is like the digital equivalent of a workspace where all the magic happens. The more RAM your computer has, the more information it can handle at once without slowing down. It's like having a larger desk to work on. You can spread out your papers and reach everything easily without having to shuffle things around. The components of RAM include memory cells, capacitors, and transistors. Memory cells are essentially storage spaces for bits of data. Each cell is paired with a capacitor and a transistor. The capacitor holds the bit of information, a 0 or a 1, and the transistor acts as a switch that lets the control circuitry on the memory chip read the capacitor or change its state. RAM operates by storing data in memory cells. When the computer needs to read data, it checks the appropriate memory cell via the transistor. Writing data involves changing the charge of the capacitor in the memory cell. This process happens incredibly quickly, allowing your computer to perform complex tasks in real time. RAM is volatile, meaning that it requires power to maintain the information stored in it. When your computer is turned off, all data in the RAM is lost. This is why it's important to save your work regularly. In essence, RAM plays a vital role in your computer's performance. It's responsible for holding all the data your computer is currently using, making it an essential part of your device's ability to function efficiently. And that, folks, is the fascinating world of your computer's RAM, the unsung hero of your digital life.